Hi, I'm going to work out the problem you referred from quiz 7.2 section, problem number 6. I picked up two different problems and I'm going to work out both of them just to show you all different possibilities. Okay, so the first one is given to be sine squared t minus secant squared t. Keep in mind every time you are working on those types of simplification problem for trigonometry, you think about the algebraic form. If you know how to handle the algebraic expression for simplification, I'm pretty sure you will have a very good clue what to do in trigonometric form. Okay, so if I had something like this one, notice two different functions are given and each one is in perfect square form. So if I had uh, known that algebraic expression is a square minus b square, I know I could write it down something like a plus b times a minus b. So I'll do the same thing for the given trigonometric form. So this one is sine squared t minus secant squared t. So I'm going to write it down just like the algebraic form. I'm going to write down sine t plus secant t times sine t minus secant t. And I cannot actually do anything else beyond this step. So that will be my final answer. Now, if I refer to my second question, which is actually the one you referred in your uh, discussion board question, this one gives you something like this: 1 over cosine x plus 1 minus 1 over cosine x minus 1. So if you notice, the two denominators are two different types of expressions. In algebra, if I have given you something like this, okay, I know for sure you know exactly how to handle this. You will come up with the lowest common denominator. So it will be a times b, and if you simplify the numerator part, it does come out to be b minus a, and that will be the final answer because you can't do anything beyond that step. In this particular case, notice I have two different um, uh, denominator. So I'm going to come up with the common denominator, which will turn out to be cosine x plus 1 times cosine x minus 1. So I'm going to simplify the numerator and it comes out to be cosine x minus 1, and there was already a negative sign with it, so I'm going to put the everything after that within parentheses. So this part will come out to be cosine x plus 1. I hope you know exactly how to simplify this part. And if you take this negative sign and distribute over each term, you can find out that these two are opposite in sign, so they will be cancelled and you are left with negative, sorry, and you are left with negative 2 over cosine x plus 1 times cosine x minus 1. Okay, so the denominator now is same as my a plus b times a minus b form, right? So I'm going to actually simplify that and come up with a square minus b square form. So this one will come out to be cosine square x minus 1 square, which is 1. And in the numerator, I still had my negative 2. And notice this part is related to my Pythagorean identity. So I actually can substitute that from my Pythagorean identity, which is sine square x plus cosine square x equals 1. And I see that cosine square x minus 1. So I'm actually going to take this one on the other side. So this will turn out to be cosine square x minus 1. and this one will go on the other side, so it comes out to be negative of sine square x. So I hope you pay attention to the positive negative sign. Do not try to do it mentally, that way you can easily miss this negative sign. Okay, so this is one of the common mistakes students make. I want you to work out the Pythagorean identity and then you simplify the given expression and then substitute. So in this case it does come out to be negative 2 over negative sine square x, and these negatives got cancelled with each other and you are left with 2 over sine square x, which comes out to be 2 cosecant square x. Since you know 1 over sine is cosecant, it will turn out to be 2 cosecant square x. Okay, and that will be the choice you will make. So that's why your final answer comes out to be 2 cosecant square x. I hope this helps.